Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
Building owner or manager in New York City? Smart Buildings NYC is your go-to guide to learn how to comply with the new codes mandated on all large buildings in New York City. Find out how the technology discussed on this episode can help your building rank higher by visiting www.smartbuildings.nyc.
Well, it is bittersweet to be introducing the final episode of this first season of Buildings and Beyond. I want to thank you all for going on this journey of podcast development with us. Or if this is your first episode, definitely go back and listen to all of the others because we really had some great conversations this season. Today, we are venturing a little into the beyond by having a guest outside of the immediate SWA team. David Unger is the founding CEO of Sentient Buildings. SWA and Sentient have a strategic partnership that I think speaks to the way that we see the term smart buildings and what it really means to us. We don't think that adding more and more sensors to generate more and more data points in buildings is smart. Smart buildings live at the intersection of behavioral science, building science, and computer science. To put it a little more simply, smart buildings bring together building systems, technology, and people. And what better person to bring the technology piece to us at SWA and to those listening to Buildings and Beyond than David Unger. Dave founded an innovative web services company in the 90s and eventually moved to become Chief Technology Officer of U.S. Energy Group. This transfer focused his technology expertise on improving the built environment, which he has fully solidified at Sentient Buildings. I'll let Dave introduce you to who Sentient is and what they do. So let's just dive right into the episode. So welcome, Dave, to the podcast. How's it going?
Good.
Good. Thanks for coming out to Norwalk, to our Norwalk office.
No problem. Glad to be here.
So I sort of introduced the topic a little bit in the intro, but I wanted to get started with your take on what the term smart buildings means to you.
So a smart building, to me, means a building that has a sense of awareness of its environment. A building that not only can sense what's going on, but can actually react to the environment in specific ways, whether that's human-controlled or that's fully automated at some level. But a smart building is a building that can actually react to its environment and control things and monitor and manage things in a way that aids in energy efficiency, aids in comfort, and also monitors and protects against major issues that could cause problems in a building. So a smart building is really a sense of awareness that the building has of itself, not an alive building in a lot of ways, but it's a building that can react to its environment intelligently, and do something.
Great. I mean, we all are loving the live walls of the plant walls that are cleaning our air. So the idea of a fully live building that's aware of itself sounds pretty good.
Right.
SWA's position, I would say, in the smart buildings, or sort of in the thought of what a smart building means, is that it's tying together the technology aspect that I think you talked about just now, and then also with the building systems and with the people, and tying these three things together. How do you think that technology relates to building systems and people?
Yeah, well, I mean, technology is really the glue that basically can take a system and integrate that system with a communication network, and then expose that network through some type of interface to a person, right? So the three pieces of a system in a smart building include those three things, really. You need a system that you're monitoring, controlling, or doing something with, that you can imbue with some level of intelligence. And then you have the technology, which includes the network. So whether that's a wireless communication network or a wired network or some way of getting data from point A to point B, and then back again from point B to point A. The network itself then can collect that data and expose that data in real time or near real time to an end user who can do something about it, or monitor the building, or collect data on the building, or analyze the data, or do something to affect the performance and operations of the building, either in real time or over time.
Great. And we talked a little bit, or you talked a little bit in the beginning about smart buildings and comfort and energy. What else can we do kind of with this technology other than monitoring energy?
Well, in the case of smart buildings, it goes well beyond just monitoring the energy systems in a building. I mean, we're talking about other systems, security systems, the elevators, the lighting, which does relate to energy, but there are many other systems that are in a building that are effectively smart and can be networked. And a real smart building brings all of these systems together into a single view, an integrated view of building operations. So you can see everything going on in a building, and the building can react. So, for example, if you have a card key access system where you can tell who's coming in and out of a building, then that affects your energy systems, right? Because then you know, okay, I need to bring this building up to temperature because I have occupants, or my occupancy has gone down, so I could reduce that. So there are a lot of things that you could do with a fully integrated system that includes much more than energy-based systems. And that's really what you have to drive when looking into this in a holistic way. Because the long-term view of this is all of the systems need to be integrated, not just the energy systems.
Right, and that's great. And I think the context now of ASHRAE 90.1 is requiring more monitoring and control of systems. And we're also having we work with a lot of projects that do enterprise green communities, and they require water monitoring. And so pulling all of these things together in one unified space sounds like really the best option.
Right. Yeah. So, and people talk about energy, you usually think about just electricity or gas, or even in New York City, district steam. But in a lot of cases, you really need to look at water and the usage of water. It's a commodity. It's a resource that we typically need to control and monitor to make sure we don't use too much of it. So
and it can cost just as much.
Oh yeah, Their water sometimes could be just as big of an expense for a building owner than the energy cost.
Right, great. So all of this sounds good. I'm on board. We're going to have all of the buildings. You can outfit my home with all the smart sensors, and it'll control myself, and the refrigerator will walk to the store and buy my milk for me. That sounds great.
Right.
But I know we have probably some people that are not as on board as you and I. So Shrikant was on the podcast a few episodes ago, and he mentioned I don't know that he said this word for word, but that monitoring is okay, but control he's not so sure about. Audi came out with this commercial that was a little anti-AI. I don't know if you've seen it, but we can link to it in the show notes. My mom refuses to drive her new Honda CR-V because the lane assist is trying to tell her what to do.
Right.
So you're talking a little bit less about smart homes and smart cars, but what are the top 3 concerns from building owners, and how do you address them?
Well, I mean, the biggest concern from a building owner by implementing a smart building is the biggest concern is how much is it going to cost me, and is it going to, deliver some type of ROI at the end of the day, or either it's going to deliver more income by allowing them to increase rent or decreasing energy costs. But the biggest concern after that is I want to make sure this is actually used, right? The concern of people that get involved in smart buildings is I don't want to be overloaded by information. Because the tendency with a lot of the building management systems over the years has been to fire out hundreds and thousands upon thousands of alarms as you identify problems with a building. Well, one person can only handle so much. And, so you want to make sure that you're tailoring and designing your smarter system to help people and augment people's lives in a way that's helpful, not that creates more work for them. So that is a real goal in designing smart buildings in a way that reduces people's workloads, because that's what that should be for. So that's a typical concern. I haven't really gotten the concern that I'm losing control, although, from an operator standpoint, they know their buildings better than anyone. So if you come in with a smart technology and say, hey, this is going to solve all your problems, it's going to be like a magic wand and the computer's going to do everything, and you just have to sit behind your desk and throw your legs up and play solitaire. That's
Sounds great.
Right. That's not really what it's designed for. I mean, the real way to implement a smart building is to work with the operators, to work with owners, and to figure out what's that proper balance of too much information versus the right information, and then also working with the operators who know their buildings, they know their buildings well, to let them know it even better, so if they could get insight that they never had before, that they really feel they need, that's what you have to address in smart buildings.
That's great. And I love that you pulled the people piece there in. And I also loved one thing you said, smarter buildings. And I think we're always talking about smart buildings as almost a destination, but thinking about smarter buildings as always, always trying to be better. There's always another, if you set up the framework, that you can then start to optimize one system at a time. And you don't need to be overwhelmed with all the data and the sensors. You can start and focus on one thing and then add in others as you have one system under control in your building.
Yeah, that's true. I mean, the point of going from smart to smarter is like the effect of learning.
Yeah.
Right? So if a building can actually learn, it becomes smarter. So that's really, in thinking about these things, once you have a fully integrated system, right, where you have, you could holistically integrate the security system, like I mentioned before, with the energy management systems and look at these things from those points of view, then you could start learning about the behavior and patterns that happen in a building. Like, when do tenants typically change the temperature in a space? How many people are typically in a room before they start getting uncomfortable? Things like that. You start learning the behavior, and the building starts to, if the building could adjust and learn from those behaviors in a way that's not intrusive,
right.
but really understand, gets an understanding, if you will, of what's going on. That's the goal, is how do you get there? And,
Right.
it's going to be a constant over the next, I would even say 20 years to get to a place where you have a fully reactive building that can react to its environment.
Right. And I want to dive in a little deeper to one of the things that you brought up, which is security. So connecting with the security system, I know that I've heard a lot of concern from clients about separating out the BMS should not touch the elevators, should not touch other things. They're worried about security concerns. I know there has been some situations in which BMS building management systems have been hacked and elevators were controlled. How do you speak to that, and how does maybe specifically for your service, but in general as an industry?
Yeah, I mean, we're living in a dangerous world right now, right? I mean, security and whoever knew that...
To scare you all out there.
Yeah, well, to scare everyone. But cybersecurity has become a major, major problem in this day and age where, our infrastructure is exposed right now in ways that are scary, right? And so how do you protect against that? And, unfortunately, the building management systems industry has notoriously been bad at protecting security. There's been stories, going back, now 4 or 5 years. Target, the
Right.
Target breach was because of a building management system that was unprotected. So there are issues where, the building owners and operators they don't want their building taken over by hackers, and their elevators all brought up to the top floor and a fire lit in the bottom floor, where suddenly their building's completely exposed in a very dangerous situation.
Right.
So you have to really, as a smart building vendor in this day and age, really think very carefully about how do you protect the building security as if it were a bank, right? Because if you think about it, bank security is very strong today. You don't hear, although it's been done, but
Right.
You have to really protect the security systems those ways, and that's protecting the network, protecting the devices, making sure that your integration to different systems has some protection on it so that you can't overstep your boundaries. And how do you create a system like that? You have to really think about it and build those security protocols into your network.
Build it in from the beginning, kind of.
Think about it from the very beginning. Every single communication point has to have some layer of protection, or a deep layer of protection on it, so it's not open to the outside world. You don't have any security holes in the system. How do you connect your system to the outside world, to the cloud or to other mobile devices? What are you exposing? how do you audit that? Most importantly is like if somebody does breach your system, how do you know it happened? So you need all of these protections in place to ensure real security in buildings. And then, I think what should emerge over time are some real industry standards around this, just like it's happened in the health insurance industry with HIPAA. There have been other, security initiatives on the banking side. So building automation systems really need to embrace these security standards and implement them system-wide. And then also they need to, work with companies that are experts in breaching those systems so that you know where your holes are. Because you don't know what you don't know unless you really do some thorough penetration testing is what it's called, to know that you can't break into the building and do some damage.
Great. And so on your platform, are you running these tests regularly, or how does that roll out, or is it?
Well, yeah, I mean, it comes down to cost, right? And so sometimes, I can't say that we're doing it every time because it really depends on how secure a building owner needs the network to be. And then also, in a lot of these cases, the security, if you can manually override a system or if you have manual capability on the ground, so if somebody does try to do some damage to the building, like shut down the heating plant or do something like that, as long as you build some protection in there that you can cut this off from being controlled remotely, you build those protections in, which are, probably the safest way to protect against real, damage and problems that may occur from a hack.
Right. I love what you said there about, if something happens, then we have this resolution, because I think that's the same way we think about building science in terms of creating the proper wall. We make sure if water gets in, well, then how will it get out of the wall? I think we have that same kind of alignment there.
Right.
If something happens, then what can we do?
Right. Yeah.
That's great. So let's go in a little, get a little more specific. Are there some case studies, some buildings that you've deployed some of your technology in, and give us the overview of what your technology means, what the different aspects of it are, and then a couple examples of projects that you've been involved with.
Okay. Yeah. So, our goal as Sentient Buildings is really to deploy wireless network infrastructure that is designed for Internet of Things or devices to communicate over. So our real objective is to, deploy that infrastructure. How do you get a wireless network infrastructure into a building that will allow you to monitor and control points wherever you want to put them without having to worry about running additional infrastructure once the network's in? Right. That's really the goal of what we're trying to accomplish as Sentient, so that we build a standards-compliant wireless device network that will allow building owners to expand and grow so that they can add control points, they can add monitoring points as needed as their needs change, right? Because their needs are not always going to remain the same. Tenants change, building ownership changes, equipment changes, things change, right? So how do you how do you design a building network that can adapt to that change? And that's what we do, and that's our philosophy as a company, is we know that things are going to change. And not only that, if you're not standards compliant, you never want to lock your customer into a situation where they're locked into a single vendor. And a lot of building owners, through some of the bigger vendors that happened to over the years. I'm not going to name names, but there are a lot of big gorillas out there that lock their customers into proprietary building management systems. So our philosophy is, how do you get standards compliant wireless capable devices in a building? And so
and standards compliant, let's dive in a little bit. What do you mean by that?
Well, there are just like there's Wi-Fi, which is a standard in effect, right? Ethernet is a standard. There are standard communication protocols so that, anytime you buy a network communication card in your computer, you plug in an Ethernet cable and you're online. Great. Well, we have the same, concept when it comes to devices in buildings, that if you buy a thermostat and you put it in your building and you have it's a wireless network in the building, you can install that thermostat wherever you want to put it, and it will communicate with the building network.
Got it. It's not like, I have ABC Company's wireless thermostat, so I need ABC Company's other module to then go to ABC Company's cloud.
Right. You can select from a multitude of vendors that all comply with the standard, so that you can get 10 different or 15 different types of thermostats, 20 different types of sensors. So you have variety, and you could go to different manufacturers, at any point. So you're not really locked in. Now, Wi-Fi is a standard. I brought that up as a wireless standard. It's not a very good one when you're doing device-level building networks, where power is a major concern in a lot of cases, where, how do you power the devices? And you don't want to run 24-volt cable or get a transformer for every single device you want to put in a building. You need flexibility. So you want low-power wireless device-based networks that will give you a tremendous amount of flexibility to wherever you want to put your sensors and your devices. And also, you want to think about, well, I don't only want to get data from the device, I want to send data to the device. Mm-hmm. So you need networks that can do both, that can transmit and receive. And that way you have full control and you have full flexibility. So once that network's in, you have a real building that can become smarter, right? We talked about, how do you make the building smarter? Well, you can make the building smarter through making the software smarter and building in artificial intelligence. But you also make the building smarter by having a lot of flexibility to where you can put points, because you don't know everything you want to measure when you start a project, and you find that out over time. So you need that flexibility so that you can reduce your cost. So that's our, just like, talking about our projects, that's where we start, right?
Got it. And then so we want this flexibility. You like to provide these flexible pieces. So say I accidentally bought with the wrong guys a couple of years ago. We installed all these sensors, and they are telling me they can only communicate amongst themselves, and I have to continue going back to this vendor. Does that mean if I want to go with you, I have to rip out everything that I've already got installed in my building, or how does that work?
Yeah, I mean, well, a lot of times it means you have to put in another infrastructure.
Right.
Right. So if you went with a vendor that was proprietary, and I'm not going to name names, but there are a lot of them out there that are proprietary, and you put that in, and, that's great. You now have to, if your thermostat network is based on this proprietary system, you're only buying thermostats from that company, and that's it, unless you want to put in a new network. Right? And if you put in the new network, then you have two different networks you have to maintain, because you have to maintain the old thermostats and the new thermostats, and nobody wants to do that. So you want a network that you put in, it's a wireless network that can support multiple different types of thermostats, so that one day you decide, what, I need some more features on my thermostat, I need to upgrade, this is compatible with this standard. We use a few standards. In Ocean is a standard that we embrace. There's also Zigbee. There's LoRa, which is now becoming a big standard out in the market. So these are all different standards that, as a building owner, when you're evaluating technologies, you should be looking at what standards the devices that you're interested in getting support. Right. So then relating that back to case studies, because I want to talk about some of the work that we've done in the area. We've worked in primarily we work in multifamily residential. We also do a lot of work in commercial office buildings, and then we've started to get involved in hospitality and in hotels. So those are really our three major areas where we're deploying our networks. Our networks can, be anything from a very simple monitoring system, where we're monitoring points that are on a boiler plant, or we're monitoring meters so that we can pull in energy data, to an advanced system that we're controlling the central plant, and we're controlling all of the terminal units in a building, bringing that all into a central system, and allowing owners and operators to control those systems remotely and from their mobile devices.
Right. And I want to break it down a little bit, because I know that we've talked a lot before about there's kind of three components, really. There's sort of the device, the individual thermostats, temperature sensors, whatever it is. There's the network, and then there's sending it to the cloud. Am I right in how I'm breaking that down?
Yeah. I mean, there's the end, what we call the edge, right? Mm-hmm. You have edge device.
Oh yeah, that's a big word these days.
Yeah, right. Edge devices, and then you've got this new term called edge analytics, which we can talk about. But edge devices are at the edge of your network, right? They're in the tenant space. They're in. They might be in an apartment. They might be in an office space. They might be on a piece of equipment somewhere in a boiler plant. But those are your edge devices, and then you need a gateway of some kind to concentrate all that data so you can do your data collection, and you could implement local control, because you don't want to control from the cloud. What if something happens with your internet connection and you lose connectivity to your building? You want the control of that building to happen continuously without network connectivity. It's something you really need to understand when you're looking at smart building systems, that there's nothing that is cloud-based that would impact the control of your building, right? And then you have those cloud-connected controls, I'll call them, where you have them connected to the cloud, but they operate independently of the cloud. And then those cloud-connected controls can send data up to the cloud. Now, the cloud is a place of infinite computing resource, right? It's where you can do a lot of number crunching. You can have a data warehouse where you can warehouse and store all your data, and then you could use that to make intelligent observations on the data and intelligence. So those are three components of a smart building. So cloud, once you bring something to the cloud, now you could start integrating other data sets and evaluating what's going on in the building, to the weather and to other things that may be happening in the building, to an event calendar, or to
dive in a little bit more into optimization rather than just sort of alarm management.
Right, and that's where you get into analytics, and you get into this process of continuous commissioning, or
Great. I like to throw in the commissioning word there.
Yeah, and right, exactly. So that you have a way of analyzing the data for fault detection, for other problems, and then you could gain insight into long-term performance issues with the building through your analytics and cloud-based systems. And then, another advantage of the cloud is then you could start bringing in data from multiple sites, and you could bring that into a central view and provide an executive level view to owners and other people who are involved in the building, so that they can at a glance get real understanding of what's going on with all their building assets.
Great. Okay, now our audience is saying you talked about case studies 3 times and you still are talking really general.
Yeah.
So let's get in. Yeah, let's get into one of those.
Yeah. Okay. So we've implemented, we did a project in the Bronx. The building is owned by Hudson Valley Property Group. It's Keith and Kelly. Keith
name.
Towers, and I think it's Keith Plaza and Kelly Towers on Southern Boulevard in the Bronx. And they have electric baseboard heaters. They had 1,500 electric baseboard heaters, and they had no monitoring, no control, no capability to see exactly what was going on with the heaters over the heating season. And electric heat, as as an engineer, is very expensive.
Right.
And
electric resistance heat.
Electric resistance heat, not heat pumps. So electric resistance heat is very expensive, and they wanted to gain some operational control over that. The new management came in, and they're like, we don't want, the heaters running nonstop during the heating season, people opening their windows while electric resistance heat is running. There's no worse condition as an owner driving by an electric heated building to see all your windows open, during December. Right, so
and they're paying for all of the electricity bills. Right,
so we installed at every baseboard heater controller that was on it was a wireless mesh network. So every device, every heater communicated with the next heater to form a mesh network.
Got it.
That all communicated to a central receiver. Each receiver can communicate to up to 500 devices. So we had to split. We had to have 2 receivers in the building. There were 1,000 in one building and 500 in another. So what we enabled the owner to do is they could see every heater in their building. They can see the thermostats. We gave the tenants thermostats so that they could set their temperature. The owner could set the limit of those thermostats remotely, so they can adjust the heat and say, we're only going to provide up to 74 degrees in all of our apartments, so that they could limit overheating. But more importantly, what we were able to do there is we were able to identify problems, like where tenants were plugging in auxiliary heaters, or opening their windows, or putting their thermostat in the freezer, which is an issue, which could happen. And so we were able to analyze data and use data analytics to say, we know that the heat has not been running. It's 30 degrees outside, so the temperature in your apartment should be dropping, yet it's going up.
Right.
Well, that means that some other heater's plugged in somewhere, right? Another example of the analytics that we're running there is the window's open, so the heat's been running nonstop, constantly for 6 hours, and it hasn't gone up a degree. Right? So in both cases you have a problem that you can identify remotely with the system, and at the end of every day we produce a report, or you can log on online and get the report and just say, okay, these 5 apartments have this problem, these 5 apartments have that problem, and then as management you can decide how you want to address it.
Great. So we're going from 1,500 units or 1,500 heaters. I can't remember what you said.
1,500 heaters.
1,500 heaters to then down to the 5 heaters that are really causing
exactly,
problems.
That are causing problems. And then you have a good measurement of your average building temperature. And so what we're doing this year, it's a project we're implementing on top of that system. By the way, we saved year over year 23% over the prior year's heating season.
And what was building management doing with the reports that you were giving them? Did you get any feedback on that?
Yeah, we got feedback. I mean, it was a process. I mean, we learned a lot in working with the owners. Like, we learned a lot not to give them too much data.
Right.
Like, really pare it down and give them like what are the top 5 offenders. Don't give them all 50 of them.
Right.
Right. So you learn through the process so that they can have a set of data that they can easily work with. Right. So that was a learning experience for us in the process and working with the owners. And the other thing we determined by putting this project in place was we determined that you can actually control your demand in the building during heating season so that you could limit your demand with some intelligence, so that you can rotate heaters off that are closer to set point for short periods of time. And then so that way you don't have, you can shed load by 20%, right? So that you can do peak load shaving and manage your load a little better. And we're going to be implementing that this season.
Wow, that's great.
Yeah, that's exciting. So that was one project. We did another project in Astoria, Queens, also on the heating system side. And then I'll talk about a cooling system we did. Great. 2 cooling systems. This was a project that we worked in concert with Con Ed on as a R&D effort. To control radiator valves, like at the valve level, to actuate the valves.
Great, on steam radiators.
On steam radiators, yeah. It was a one-pipe steam system, I think SWA was involved this year. The SWA, right. We just did a orifice plate a replacement there as well.
Great.
But you controlling thermostatically the valves in each apartment, in each room.
Great.
And so we had thermostats that were communicating wirelessly to the valves and also wirelessly to the building management system. We tied that into the boiler system so that all of the thermostats can report whether or not they were calling for heat. Right. So if we knew that way, it was a good way of determining, do we have demand? Is there a demand for heat right now? If all the radiators are closed and nothing's calling, we're shutting off the boiler. Great. Right. So it was just a better way to control the building.
Without impacting occupant comfort.
Impacting occupant comfort. However, that building needs to have its risers insulated. Another thing that we discovered in this process. It's great if you could turn off all the radiators, but then suddenly you're heating your building just through your riser piping.
Right.
It was a lesson learned.
Hashtag whole building solutions.
Yeah, hashtag whole building solutions. And that's why we got Stephen Winter Associates involved, at this point. Now, hopefully this season we're going to be all set. I still don't think they've insulated all the risers. They're starting to make an effort to do that, but we're making progress.
Great.
And then just on the cooling side, this is in the commercial building world. We've been working with Con Ed on their demand management program. So we did about 3 years ago a project for Newmark Knight Frank, right in Times Square. They have a building that has 20 package units. Controlled. They have a cooling tower that provided condenser water for half of the units. Half the units were air cooled, half the units were water cooled. It had a cooling tower. So what we did is we installed a system to do peak load shaving, same concept as we talking about on the heating side. But during the summer months, from the peak period, from 1 1 p.m. to 6 p.m., we analyzed the load of all of the units. We had meters on every single air handler, and we had a meter on the cooling tower so that we knew the KW in real time load of all the systems.
Okay.
So we did a predictive load control system where we watched as we started to approach peak, it started to shed. The system intelligently reacted and would shed the second stage of the compressors on a select group of compressors, and then would rotate so that they would rotate through these compressors. So you wouldn't hold them off for any length of time that would cause a noticeable comfort issue, but you would do it just enough to get 3 to 4 kW per compressor out of the peak, so that you could shave that load. In this case, 50 to 75 kW.
Okay, great. And did you look at all at, in that context, we kind of have energy consumption versus maybe cycling of the compressors. Did you look at all at making sure, you had minimum runtime on for the compressors and making sure that you have sort of, that you're not short cycling?
Yeah. Oh, yeah. Yeah. We would monitor the short cycling so that we're not, turning the units on and off constantly.
Right.
There'd be some delay times on the on-off cycles. We were intelligently looking at that and controlling that properly. And we were doing it holistically as well, so that what you can also do with this system is, you don't want to bang on all your compressors at the same time at 7 a.m. when everybody, when all the air conditioners kick on at the same time.
Right.
You want to stage them. So you can build in intelligent staging of these units so that you don't have a system where you get overloaded and you get a load spike, and that causes a peak demand issue.
That's awesome. Well, I could talk for hours and hours about energy efficiency, but I like to kind of wrap it up with a question of, if we invite you back on this podcast in 5 years, what are we going to be talking about then?
Well, in 5 years, we're going to be working in the field of artificial intelligence, and the systems are going to start to self-optimize. We're going to have enough data. I mean, a lot of this comes down to how much data you're collecting and how much you can interrogate and then learn from the data set. So, in 5 years, my goal, at least for the company and where we want to go, is to build real artificially intelligent building management systems that can continuously optimize the system, and so that it doesn't necessarily need human intervention and constant watching.
Right, that's great.
That'd be the goal.
Great. And then as a side gig, if you could work on my refrigerator that gets the milk from the store, that would be great.
Yeah, I would be happy to. Yeah,
Awesome.
We'll get the smart Samsung refrigerator working in your house.
Great. Thank you. Well, thank you so much for coming out and being on the podcast.
Thank you.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode's show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.